Welcome to Basic Electrical Engineering lecture series. This is a series of lecture videos for the first year engineering and electrical diploma students. In these videos, fundamentals of DC and AC circuits, network theorems, fundamentals of transformers, DC and AC machines, and renewable energy sources are the topics covered. Sufficient number of numericals are worked out in each session to make the concepts clear to the viewers. For a basic idea about the topics mentioned, please watch these videos from the very beginning itself. If you find the videos useful, please subscribe for the channel, like the video, and press the bell icon for notification. Please try to wear a headphone and watch the video for better sound clarity. Thank you all. And now let's start with today's session. So let's start today's session. Today's session is on phasor operations. Now we have to add two quantities, electrical. Here we are normally representing electrical quantities, voltage or current. But for adding two physical quantities, we can use the same method. Here, if two forces are represented by 10 angle 30 and 8 angle 60, we can add those forces and find the resultant using this method. So here, we call these quantities phasors because phasor is basically a rotating vector in which frequency is also involved. Say 10 angle 30. Here the two phasors to be added are, it can be currents or voltages. So the quantities to be added are 10 angle 30 and 8 angle 60. So 10 angle 30, the vector has a magnitude of 10 units and it is at an angle of 30 degree with the reference. Now we can resolve this vector into directions, positive x and positive y directions. So I'll mark this point as O, A, B. So OA is equal to 10 into cos 30 and AB is equal to 10 into sin 30. Because OBA is a right angle triangle, OA is equal to OA by OB is cos theta. So OA is equal to OB into cos theta or 10 into cos theta or 10 into cos 30. Similarly, this AB is the opposite side. So AB divided by OB is sin 30. So AB is equal to 10 into sin 30. So 10 into cos 30 is 8.66. So this is 8.66 units. 10 into sin 30 is 10 into 0.55 units. So we can represent this vector or phasor as 10 angle 30 or 8.66 plus J5. So this is, we know that in the previous session we have seen this. So this is polar form of representation. This is rectangular form of representation. So for adding these two phases, so this is the first one, OA, which is OA is 10 units. This angle is 30 degree. OB, it is 80 units and the angle is 60 degrees. So to add these two, to perform addition, we can convert it into rectangular coordinates so that it can be easily added. So tan angle 30, we can convert to rectangular form, that is 10 into cos 30 plus j 10 into sin 30. 10 into cos 30 is 8.66, 10 into sin 30 is 5. Similarly, this 8 angle 60 also is converted to rectangular coordinate 8 into cos 60. So cos 60 is 0.5, 8 into cos 60 is 4. Then 8 into sin 60 is 6.93. So 8 angle 60 can be converted to rectangular form as 4 plus j 6.93. So in this, the real components can be added. Real parts are 8.66 and 4. That is 12.66. Then imaginary parts can be added. Imaginary parts are 5 and 6.93. And it is 11.93. So the resultant phasor is 12.66 plus j 11.93. That is converting back to polar form. So it can be converted to polar form as the magnitude can be obtained by square root of 12.66 square plus 11.93 square. So this is 17.395. And tan inverse, the angle can be obtained by tan inverse 11.93 divided by 12.66. So in from rectangular form, it can be converted to polar form by finding out the magnitude using the equation square root of 12.66 square plus j 11.93 square. So it is like this 12.66, this is 12.66 plus j 11.93. This is the magnitude of the resultant phasor. That is, it's a right angle triangle. This angle is 90 degree. So the resultant is square root of 12.66 square plus 11.93 square. And this angle is equal to tan inverse 11.93 divided by 12.66. So the resultant phasor can be expressed in polar coordinates as 17.395. This is 17.395. Angle 43.3. So if graphically if you want to do it also, say this OA is 10 angle 30, OB is 8 angle 60. So I am drawing OA with the magnitude as 10 units at an angle of 30 degree with x-axis. And to that we have to add OB. This is OA and this phasor should be added to this. So bring it here. So same direction, same magnitude, same phasor can be brought here and added to this one. That means, or in a simple way, we have to convert, we have to complete the parallelogram and draw the diagonal. That way also we can do it. So this phasor will be move it slowly and bring it here. The direction should be the same. Magnitude also is the same. So this is the result. So if OB is 80 units at an angle of 60 degree, then the resultant will be, this will be 17.395 and this angle will be 43.3. So this is how it can be done graphically. Now next is subtracting. Now we have to subtract 8 angle 60 from 10 angle 30. So this is 10 angle 30. We have to subtract 8 angle 60 from that. So we can subtraction also is to be for performing subtraction. We have to convert to rectangular coordinates. 10 angle 30 when we express it in rectangular coordinates, it will be 10 into cos 30 plus j 10 into sin 30 minus 8 into cos 60 plus j 8 into sin 60. That is 8 into cos 60 is 4, 8 into sin 60 is 6.93. 8.66 plus j5 minus of 4 plus j 6.93. So 8 minus 4, 8.66 minus 4 is 4.66. 5 minus 6.93 is minus 1.93. So converting it back to polar form, square root of 4.66 square plus 1.93 square, that is 5.043, and tan inverse minus 1.93 divided by 4.66, that is minus 22.5 degrees. Now it means graphically when you are doing it, 10 angle 30 minus 8 angle 60. Now this is, if we, then the same can be done as 10 angle 30 plus 8 angle 60 plus 180. By adding 180, the sign can be reversed. So if we add 180 degrees, the phasor will be diametrically opposite to the original one. So what we are doing here is, graphically when you are doing it, subtraction means we can, this minus sign, we can convert it to a plus sign by adding 180 degrees here. That means we are reversing the direction of the phasor. So this is 8 angle 240 degree. It is from here, measure up till here. It is 240 degree. Originally it was here at 60 degrees. We are adding 180 degrees so that the phasor is here. Now we can perform addition. So this 10 angle 30, this phasor, slowly move it and bring it here. Same direction, same angle. So this is the resultant. So the resultant is 5.043 angle. This angle is 22.5 degrees. Because it is taken in clockwise direction, it is minus 22.5 degrees. If we take in counterclockwise direction, it will be plus, it will be 360 minus 22.5. So here we are measuring from positive x direction in clockwise manner. So it is minus 22.5. So addition and subtraction can be performed by converting the original phasors to rectangular coordinates. Then add or subtract the real components, add or subtract the imaginary components. This is the result in rectangular coordinates converted back to polar if necessary. Now next is multiplication. Here the same phase is 8.6 plus j5 into 4 plus j 6.93. This can be multiplied using a plus b into c plus d equation. But it is easy to convert it to polar coordinates and then perform the multiplication. So 8.66 plus j5, you know that it is 10 angle 30. 4 plus j 6.93 is 8 angle 60. So for multiplying, multiply the magnitudes, that is 10 into 8, and add the angles 30 plus 60, that is 90 degrees. So the result is 80 angle 90. That is the resultant. So multiplication can be performed by converting the rectangular coordinates into polar form. Then multiply the magnitudes and add the angles. Next is division. So here 8.66 plus J5 divided by 4 plus J6.93. Convert the quantities to corresponding polar form. 8.66 plus J5 is 10 angle 30 and 4 plus J6.93 is 8 angle 60. So divide the magnitude 10 divided by 8 at an angle of 30 minus 60. Subtract the angles. 10 by 8 is 1.25. 30 minus 60 is minus 30. This is the resultant. This is how addition, multiplication, addition, subtraction, multiplication, and division are performed on phasors. Now the next is AC through resistance, inductance, and capacitance. First one is AC through resistance. Now a voltage of V is equal to Vm sin theta is applied across a resistor. Now there will be a current through the resistor. Current also will vary in the same way as voltage because current through the circuit I is the instantaneous value of current through the circuit and its value can be obtained by Vm by R into sin theta, or we can write it as Im sin theta. So the current through the circuit is Vm by R into sin theta or Im sin theta. The maximum value of current through the circuit. Current through the circuit is always proportional to the voltage and its value is V by I. So the current, the corresponding RMS values. Here this is the instantaneous value. Corresponding RMS value can be obtained by V is equal to Vm by root 2. This is the instantaneous value of current. Corresponding RMS value is Im by root 2. I is equal to Im by root 2. So this RMS value can be represented as phases like V, I. Both are in the same phase. So if you want to represent it as waveforms, the voltage waveform and the current waveform. When voltage waveform reaches maximum, current waveform also reaches maximum. When voltage waveform is at 0, current waveform is also at 0. This is V, this is I. So in a resistor, we can say voltage and current phases are in phase. So the variation is similar or identical manner they vary. Identical manner means when voltage is 0, corresponding current also will be 0. When voltage, the instantaneous value of voltage when it is maximum, current is also maximum. So this is the variation of current or alternating current in a circuit which has only resistance. Now let's take inductance. So assume a voltage V is equal to V, an instantaneous voltage V is applied or a voltage is applied across an inductor whose instantaneous value is V. Now there will be an EMF induced in the inductor, which we have seen E is equal to, we have derived an equation also for that, minus N into d pi by dt, because it is always opposing the applied voltage. So for simplicity, let's take N is equal to 1. So E is equal to minus d phi by dt. So the applied voltage can be expressed as d phi by dt plus d phi by dt. Because these two quantities are always opposing. The EMF induced across the inductor and the applied voltage are always opposing. So the net voltage in the loop is always zero. So we can express it as d phi by dt. So we know that the flux is proportional to the current through the circuit. I is the current through the circuit. The flux is proportional to current. So we can write flux as, since flux is proportional to current, flux can be written as a proportionality constant L into I. So flux is proportional to a proportionality constant L into I, where L is called coefficient of self-induction. Coefficient of self-induction or self-inductance. So d phi by dt can be expressed as L into di by dt because flux and current are proportional. Now assume that I is equal to, I is expressed as Im sin omega t. We are taking I in the reference direction. So I is expressed as Im sin omega t. So when we substitute it here, V is equal to L into di by dt or L into d by dt of Im sin omega t or L into Im into omega into cos omega t. When we differentiate the equation, V is equal to L into di by dt. Substitute I with Im sin omega t and differentiate, we will get it as L into Im into omega into cos omega t. So combine this term omega and del and express it as XL, where XL is called inductive reactance. Inductive reactance. So XL is equal to omega L or 2 pi Fl. So the equation can be written as instantaneous value of voltage is equal to XL into Im sin Im cos omega t. Cos omega t can be written as sin omega t plus 90. When we expand this, you will get cos omega t. So when we expand sin omega t plus 90, sin omega t cos 90 plus cos omega t sin 90. First term is 0. Cos omega t sin 90. Sin 90 is 1. Therefore, the equation can be expressed as cos omega t can be expressed as sin omega t plus 90. So equation for V is equal to, now XL and Im multiply. XL is a constant for a particular configuration. XL into Im is Vm, maximum value of voltage, into sin omega t plus 90. So the equation for voltage, we are getting it as Vm sin omega t plus 90. So I, we have taken it as Im sin omega t. We are getting it as Vm sin omega t plus 90. So the applied voltage from this, it is clear that the applied voltage V is leading the current I by an angle of 90 degree. The voltage applied here is leading the current through the circuit by an angle of 90 degree. So let's take the RMS values now. V M divided by root 2 will give the RMS value of the applied voltage. Im divided by root 2 will give the RMS value of current through the circuit. So here we have taken I in the reference direction. So this is I. And V is leading I by an angle of 90 degree. So this angle is 90 degree. So this is the applied voltage, this is the current through the circuit, and the phasor relationship between these two quantities is that in an inductor, the applied voltage is leading the current through the inductor by an angle of 90 degrees. Next, let us take the capacitor. AC through capacitance. Now here, let the applied voltage V is equal to Vm sin omega t. Now there will be a current flow through the circuit only when the applied voltage is changing. If we apply DC or a steady unidirectional voltage across a capacitor, the capacitor, as long as the capacitor is being charged, there will be a current flow through the circuit. Once the capacitor is fully charged, there will be no current. So there is variation of current in the circuit, or a current will flow in the circuit only when the voltage across the capacitor is changing, or when the applied voltage is changing. So the basic equation for current through the circuit is C into dV by dt. Capacitance, say if it is a parallel, it's a constant. For a parallel plate capacitor, suppose there are two parallel plates. And the capacitance of this configuration can be written as epsilon A by D. A is the cross-sectional area of the parallel plates. This is A meter square. And D is the separation between them, D. Epsilon is called permittivity of the medium. That depends whether it is air or paper or mica, whatever it is. Epsilon is the permittivity of that medium. So it's for a particular configuration of capacitance, particular configuration of the capacitor, the value of capacitance is constant, epsilon A by D. So I is equal to C into dV by dt. So applied voltage, let's take the applied voltage as Vm sin omega t, and finding the value of current. I is equal to C into dV by dt. C into d by dt of V, it is Vm into omega into cos omega t. Now, this quantity omega c can be combined. So, omega c is the reciprocal of capacitive reactance. Xc is called the capacitive reactance. Capacitive reactance Xc is equal to 1 by omega c. So, this omega c can be replaced by 1 divided by reciprocal of Xc, 1 divided by Xc. So the equation can be written as I is equal to 1 by Xc into Vm into cos omega t, again can be written as sin omega t plus 90. So Vm by Xc, the applied voltage divided by capacitive reactance, that is Im. So equation for I becomes Im sin omega t plus 90. So this equation shows that current is leading the applied voltage by an angle of 90 degrees. So taking the RMS values, I is the RMS value of current, V is the applied voltage, I is leading V by an angle of 90 degrees. Now let's work out some examples. Now a voltage of 141.42 sine 314 T volts is applied across a series circuit having R is equal to 10 ohm and L is equal to 0.1 Henry. Obtain an expression for current. A voltage of 141.42 sine 314 T V. This is the general form. So V is equal to Vm sine omega t. Is expressed in this form. So Vm is equal to 141.42 and omega is 314. Frequency, if you want, you can find out omega divided by 2 pi. So resistance is 10 ohm, inductance is 0.1 Henry. So if we draw the circuit, R is equal to 10 ohm and inductance L is equal to 0.1 Henry. This is 141.42 sine 314 T. Vm, this is the maximum value of voltage. So we'll do the computations in RMS values. So RMS value of applied voltage is 141.42 divided by root 2, that is 100 volts. Now the RMS value of current through the circuit can be found by, first we have to find the impedance of the circuit. R is equal to 10 ohm. Inductive reactance XL is equal to omega L. So omega is 314 into L is 0.1 Henry. So it is 31.4. It's the inductive reactance. So the impedance of the circuit can be written in rectangular form as 10 plus J 31.4. Converting it to polar form, the magnitude is square root of 10 square plus 31.4 square. Square root of 10 square plus 31.4 square. Angle tan inverse 31.4 divided by 10, that is 3.14. So it is 32.95. This value is 32.95. Tan inverse 3.14 is 72.33 degrees. Now how the phasor diagram will be? Now we have to find out the current. Obtain an expression for current. This is impedance only. Impedance is 32.95, angle 72.33. So V is 100 angle 0. So current is equal to V by Z. That is 100 angle 0 divided by 32.95 angle 72.33. Dividing 100 by 32.95 is 3.035. And the angle is 0 minus 72.33 minus 72.33. Now in this question we are asked to find an expression for current. So this is the RMS value of current. So in the expression you have to put maximum value. So 3.035 into root 3. Maximum value 3.035 into root 2. That is 4.29 into sine omega t. Here angle is 72 minus 72.33. So in this expression for current, the expression is sine 314t minus 72.33. That means current is lagging behind the voltage by an angle of 72.33 degrees. Now the phasor diagram will be, this is V 100 angle 0. This is I. Magnitude of I is 3.035. This angle is 72.33 degrees. So this phasor, I'll mark it as OA. OA is equal to I into R. I is 3.035 into R. R is 10 ohm. 3.035 into 10 is 30.35. This phasor AB is I into XL. So OA is I into R. AB is equal to I into XL. So this angle is 90 degree. So OB is 100 only. OA square plus AB square will give you 100. OA is I into R, that is 3.035 into 10, 30.35 volts. VL is I into XL. I is 3.035, XL is 31.5. So you'll get a 95.299. So V is square root of VR square plus VL square. VR is OA, I into R. So this is OA, this is AB. We can represent it as OA as VR also and AB as VL, voltage across the inductor. VR is voltage across the capacitor. Solve it, you will get 100 volts. So from this is I into R. This side is I into XL. This is I into Z. So from this you can write the relation I square Z square is equal to I square R square plus I square XL square. And cancelling I square throughout, Z square is equal to R square plus XL square. So result can be found also by square root of square plus XL square. So we found an expression for current. And now next is a voltage of 141.42 sine 314 T volts is applied across a series circuit having R is equal to 10 ohm and C is equal to 0.1 millifarad. Obtain an expression for current. Draw the circuit. R is a capacitor. Alternating voltage is applied across it. This R is equal to 10 ohm. C is 0.1 into 10 to the power of minus 3 farad. Now Vm is 141.2, therefore RMS value of voltage V is equal to again 141.42 divided by root 2, that is 100 volts. So here also to find the current through the circuit, we'll find the RMS value of current. RMS value of voltage divided by impedance of the circuit. So R is equal to 10 ohm. Capacity or reactance we have to find out next. R is equal to 10 ohm. Xc is equal to 1 by omega C. 1 by omega C is 1 divided by omega is 314. C is 0.1 into 10 to the power of minus 3 or 10 to the power of 3 divided by that is 31.84. So Z is written as R minus JXC. R minus J 31.84 in this case. In previous example, it was inductive reactance R plus JXC. Here, capacitive reactance R minus JXC. So it is 10 minus J 31.84. So converting to polar form, we will get square root of 10 square plus 31.84 square is 33.37. So this is square root of 10 square plus 31.84 square. So this angle is tan inverse minus 31.84 divided by 10. You will get minus 72.56 degrees. That is the impedance of the circuit. Now current is equal to voltage divided by impedance, that is 100 angle 0 divided by this quantity 33.37 angle minus 72.56. So the RMS value of current is 2.996. So I is equal to 100 angle 0, 100 angle 0 divided by 33.37 angle minus 72.56. 100 divided by 33.37 is 2.996. 0 minus 72.56, that is plus 72.56. So if an expression for current is to be written, then this is the RMS value converted to maximum value by multiplying with root 3 or root 2. So 2.996 into root 2. 2.996 into root 2 sine 314t plus there is an angle here. Current is leading here. So at an angle of leading by an angle of 72.56. So in the expression for current, it is sine omega t plus 72.56. So current is leading the voltage here. So phasor diagram, this is the current phasor, this is the reference. Current is leading by an angle of 72.56. So this is 72.56 degrees. O A is equal to I into R, because I into R is in phase with I, and I into XC, this is, let's take it as AB. AB is equal to I into XC. So the voltage across the capacitor, the component of applied voltage across the capacitor, that is lagging the current by an angle. Current is leading the voltage, or voltage drop is lagging the current. So we'll go in the clockwise direction. Clockwise direction, this is I into XC. OB is the applied voltage V. Once more I'll tell you. This is the current vector which is leading the reference by an angle of 72.56 degrees. OA is the air drop that is in phase with the current. Then AB is the voltage drop across the capacitor. So in capacitor, the angle between the current through the capacitor and voltage drop across the capacitor, that is 90 degree out of phase, and current will be leading the voltage drop by an angle of 90 degrees. So voltage drop has to lag the current. So AB is 90 degree lagging behind the current. This angle is 90 degree. So proceed in the clockwise direction, take 90 degree in the clockwise direction, proceed. This AB is I into XC, and OA plus AB is equal to OB. OB is the applied voltage V, which is 100 volts. So VR is equal to, here in the phasor diagram, current OA. This OA is 29.96 volts, and AB is VC, which is 95.392 volts. So A square plus AB square will be 100. This is the applied voltage V. This is I into R. This is I into X. The last example, one more example. A voltage of 141.42 sine 377t volts is applied across a series circuit having R is equal to 100 ohm, L 1 Henry, and C is equal to 5 microfarad. Obtain the current, voltage across R, voltage across L, and voltage across C. So here the applied voltage in is equal to 141.42 sine 377t. That is maximum value is 141.42. Omega is 377 and the circuit R is equal to 100 ohm, L 1 Henry and C 5 microfarad. Let's draw the circuit. R, L and C. So RMS value of voltage is 141.42 divided by root 2. So V is equal to 100 volts. So R is 10 ohm, 1 Henry, 5 microfarad. So total impedance of the circuit is R plus JXL minus JXC, or R plus J omega L minus J into 1 by omega C. So you can calculate and write R is 100 ohm, XL omega L. Omega L is 377. Omega is 377, L is 1 Henry, so 377. Minus J, 1 by omega C can be, or it's calculated and its value is 530.5. So impedance is 100 minus J, 153.5, or in polar form, it is 183.2 angle minus 56.9. This is the value of impedance. So current through the circuit is 100 angle 0 divided by 183.2 angle minus 56.91. When we are dividing, 100 divided by 183.2 is 0.54585. Angle 0 minus minus 56, that is plus 56.9. So the expression for current is, this is RMS value, multiplied by root 2 is 0.54585 into root 2 is 0.7719 sine 377t plus 56.91. Current is leading. Net current in the circuit is leading. So voltage across the resistor, that is VR, RMS value of current into, well, this is not 10 ohm, sorry, this is 100 ohm. Okay, RMS value of voltage across the resistor is 0.54585 into 100, 54.58 volts. Then voltage across the inductor is I into XL, that is 0.54585 into 377, 205.78. Voltage across the capacitor I into XC, I into XC is 530.5, 289.57 volts. Now the phasor diagram, I is equal to, I'll write down the value here, 0.54585 angle 56.91. That is, this is the current. Its magnitude is 0.54585. This angle is 56.91. Then again I'll mark OA. This is B and this is C. OA is I into R or VR is equal to I into R. So VR value is 54.58. This is 54.58. That is in phase with I. Then AB is VL. Sorry. AB is VL. VL is 205.78. So in inductor, the voltage drop should lead the current. So from this direction, counterclockwise will take 90 degree and draw VL. Inductor current is lagging the voltage or voltage drop is leading the current. So VL should lead I by 90 degree. So from the direction of OA, I'll take 90 degree counterclockwise and mark AB. AB is 205.78. Then VC is, that is voltage drop across the capacitor, is 289.57. That is BC. So the direction of BC is in capacitor, current leads the voltage or voltage drop should lag the current. So from this direction should go 90 degree clockwise and mark BC. So the resultant is OC, that is 100 volt. That also can be obtained by V is equal to VR square plus VC minus VL the whole square. So this OAC is a right angle triangle. OA is equal to VR and this length is VC minus VL. So the net voltage can be expressed also by as VR square plus VC minus VL the whole square. So it is 54.58 square plus 289.57 minus 205.78 the whole square is equal to 100 volts. So this OA is the voltage drop across the resistor. It is in phase with the current. AB or VL, voltage drop across the inductor. It is leading the current by 90 degree. It is BC is the voltage across the capacitor, BC. That is lagging the current by 90 degree. Magnitude of VL is 205.78. Magnitude of VC is 289.57. So marking, that is VR plus VL minus VC, you will get OC, which is the resultant voltage. So that's all for today's session. So if you like the video, please share it among your friends and subscribe for the channel. And thank you for watching.